how to automate the detector or vulnerability scanner for Log4Shell remote code execution Log4j CVE 2021-44228. I'm going to show you in a live demo with some simple Ansible code. I'm Luca Burton and welcome in today's episode of Ansible Pilot. What is Log4Shell remote code execution Log4j CVE 2021-44228? Remember 2014? Heartbleed was a bug of OpenSSL, the most popular open source code library for Transport Layer Security (TLS) and Secure Socket Layer (SSL) protocol, used for encrypting websites and software. At the time, the flow allowed to read confidential information, allowing the hacker to trick a vulnerable web server with encryption keys. Back to the present. Log4j, the Java program compromised by the Log4Shell bug, is a widely used multi-platform open-source Java logging framework library, developed and maintained under the volunteer Apache Software Foundation. Log4j is widely used on web servers to record users' activities to analyze later by security or development teams. Hackers could use the Log4Shell flow to access sensitive information on widely of device, plant ransomware attack, and take over machine to mine cryptocurrency. The vulnerability was discovered almost by happenstance when Microsoft announced it has found suspicious activity in Minecraft Java Edition, a popular video game it owns. The flaw was officially funded by Chen Zhayun of Alibaba's cloud security team on the 24th of November 2021. Some estimation by Wiz and AI, the vulnerability affects 93% of enterprise cloud environment. Affected commercial services include Amazon Web Service, Cloudflare, iCloud, Minecraft, Java Edition, Steam, Tencent, QQ, and many others. Demo. A real-life demo how to automate the Red Hat Detector Log4Shell remote code execution Log4j CVE 2021-44228 on Linux with Ansible Playbook. Are you ready? Let's have fun! Wait a minute. Where I could find more information about this bug, you probably remember that Heartbleed Blood has a really nice web page where all the information was shared. Yes, unfortunately is not available for Log4Shell. So you need to start from Wikipedia, but there are better places where to move forward about these security things. Let me share with you. Do you want more information about CVE 2021-44228? Go directly to MITRE.org and you have all the affected version and the security bulletin from all the major company involved. As you can see, there is a lot of fun here. And moreover, if you want more investigation information, I will suggest to go to the NIST, the National Vulnerability Database, directly from the United States government. As you can see here, you have the severity classification and all the reference, advisory, solution and tools. And this is a great resource. I really recommend you to take a look. In my demo, I'm going to reference the Red Hat Security Bulletin CVE-2021-009 Log4Shell, that is pointing to CVE-2021-4428. As you can see, it was published on December 10th and was updated on yesterday, so 21st of December. The impact is critical, so take a closer look, and I really appreciate that Red Hat is sharing all the affected product for all the customer, and especially on the technical information. There are a lot of information about the mitigation and more technical detail, also the impact on cloud services, and all the affected product that has already a security advisory, how to fix and patch it. But the most important part is this detector script that, as you can see, is a simple bash script that you can download from the website, and allowing to download is going to download this bash script to test if your system is affected, and we are going to automate the execution of this code in our playbook. Let's take a look on the reproducer in my editor. So first of all, let's open the bash script. As you can see, it's very long code wrote by Red Hat engineers to verify if a version is affected or not. The most important part is the usage part, where you could specify the scan path, so the path where your web application runs, usually under var, and TMP path is where the detector is going to do all its job and also save a report. This detector need a library, exactly unzip program installed on the machine. You can see this on line 300. As you can see, you need to have unzip, stat, sha, 256 sum, and some other utility installed on the machine. I'm going to manage in my Ansible code, so let's take a note. Whatever. The code is quite complex. As you can see, basically is going to verify if the version of log4j is the one of the one affected, but is not able to understand if you already did some mitigation. But this is quite good. At least you have general advice if your system is affected or not. And let me highlight more. As you can see here, there is the finding of log4j exactly inside your code, and here you can have a more deep understanding on what your code is doing for comparison. Each result is going to be saved on the TMP path, and basically this code is going to return 0 if your system is not affected, and a different result if it is. And very interesting is, let me take a look, you can see that there is going to save a txt file inside the run path. Here we go, exactly. You have this file log4j path.txt inside the TMP directory, so there is going to save more technical information if your system is vulnerable, and you can deep dive on this. I think it's a great code. As you can see, it's more than 1600 lines of code, and is quite useful. So now we are going to use it. Another important thing that Red Hat is providing is the PGP signature of the detector or scanning script. So you are able to verify that the code that you are running is 100% the same of the one released by the security team. This is very important, especially in this type of investigation. So you are 100% sure that the code is the one right for you and not being altered in any way from other man in the middle or other type of attack. So we need to verify that the code that we downloaded is the one provided by Red Hat before running the code. And we are going to do all these things in one Ansible Playbook code. First of all, let me start my vars.yml, where I put some variable and trigger that I would like to use in my Ansible Playbook. Let me begin with one comment. Let me add the Red Hat Detector information and Red Hat Detector and the URL of the page, so everybody can download this documentation. Let me start with sh_detector variable that is going to save the file name of the Red Hat detector, in my case CVE, etc. sh_signature is going to have a file name of GPG signature, so same name .asc as extension. And detector_base URL is the web address where we download this file from. So it's going to be the full path https://access.redhat.com, then there will be /sites/defaults/files. Here we go. This base path will combine with detector and signature to download this file from the web. After this, I would like to define detector_path that will be the file system path to scan. Let me put default to /var, because probably web app will be under var file system. Bear in mind that the detector script need to be in a different path. Exactly, I'm going to download and detector_dir, so /tmp/CVE-2021-4428. The TMP path need to be with executable permission. So if you run with no exec TMP, you need to use a different path. And the detector_rundir is the TMP path of the detector script. In my case, will be TMP will be the place where the report will be saved. Detector_option will specify some command line option -n -d -no progress -scan, and here we specify the path to scan, the value of detector_path in my case, and another important thing is GPG_key ID, where we store this is the official Red Hat product security key. This GPG key ID is released officially by Red Hat product security team, so I need only to copy and paste from the website. And let me add GPG public key. This is the full command line that is going to be executed. So GPG key server, for example, gpg.mit.edu, but you can choose your favorite one, and -- receive, and the key ID that we just defined a few lines before. Let me add also some boolean clean run before. This is for clean the run directory before execution, and delete after to delete all the detector dir after execution. I prefer to keep on false, so just in case you would like to review the result. Verify GPG is a boolean that allows me to enable or disable the GPG signature verification. In my case, I'm keeping to true because I think that you really want this feature. So as you can see, we defined some variable that we are going to use in our Ansible playbook to perform all the tasks, to download the detector from Red Hat website and the signature, verify the signature and run from command line. So let's jump to the Ansible playbook where the fun happens. Are you ready? Let's go! Great, now we have a variable configured. Let's move to the main playbook where the action happens. So first of all, let's begin our playbook with a YAML header, 3-, and let's give a name, Detector for Apache log4j, and let me specify also the CVE number, so CVE-2021-009 Here we go. We would like to target hosts all of our inventory, and I need become set to true because I would like privilege escalation with root. So all the command following will be executed by root. Let's begin our tasks list. So first things include _vars to include our variable file. In my case is vars.yml. All the things that we defined before. First step will be to install, verify that dependency are present on the target machine. I'm going to use ansible.builtin.package, so we can cover all the Linux distribution with this, and package is unzip state present. Let me also add update _cache true to refresh the package manager cache. So next task, name, create detector directory. This is the directory where we downloaded the file and we perform also the execution. We need ansible.builtin.file parameters. So first of all, we specify the path. In my case, will be the value of the variable detector _dir, not path, is dir. Here we go. And the state will be directory because we are going to create a directory. Here we go, easy peasy. Next task will be to name, download the detector from the Red Hat website. In this task, I'm going to download the bash detector and also the signature file using ansible.builtin.get_URL module. Some parameter, first is URL. Let me compose using the value of detector. What is a base URL? What was the variable detector _base URL? Here we go. And let me add also the following part that is the file name. In my case, I'm going to use a loop, so let me use the special variable item for this. Destination path will be the detector directory, so detector _dir, here we go. This is and of course the special variable item to use the same exact name as the file downloaded. On the mode, I need to guarantee the execution permission of the bash script. Yeah, technically the signature don't need, but let's simplify. So 0755 owner root and group root as well. Let me add the loop, so with underscore items, and let me specify two elements. The first is the value of a variable, in my case sh, like a shell script, underscore detector, here we go. And the second line will be the value of a variable sh underscore signature. And let me close. Okay, so this step is going to download these two files from a Red Hat website. Now we are ready to perform the GPG signature verification. So let's start with GPG public key. The first things we need to download the product security key, and I'm going to use Ansible built-in shell module, and in my case let me use the value of a variable GPG underscore, what was the command, public underscore key. Here we go. And unfortunately there is no GPG direct module, so we need to rely on the shell. And let me also add a condition, in my case when verify underscore GPG is true. Not the value of is true. Here we go. So this step will be omitted if we don't want the GPG verification, but I really recommend because it's very easy and automatic with Ansible. Now we are ready for the GPG verification process. So we technically are going to verify the signature against the detector bash script. So with ansible.builtin.shell, again, let me specify the command line. In my case will be GPG and then some dash verify. Okay, first will be the path of the signature. So under detector dir, here we go, we combine together with the signature, so sh underscore signature. Here we go. Let me close the variable and now specify the file to verify. So that will be under detector dir. Here we go. Very easy to combine together. And let me add also, in my case is sh underscore detector. That is the bash script that we would like to verify. GPG is going to return 0 if the key is okay, so will be fantastic. Let me also perform this when verify underscore GPG equal true. Again, let me correct equal true. So this two step will be omitted if we specify verify GPG false. Let me add more. Finally, we are ready to execute. First of all, let's verify the directory. Let me remove any directory, run directory. First of all, remove any detector run directory. So, ansible.builtin.file, the path will be under detector underscore dir. You see that using variable is very comfortable in Ansible, so that will be the detector tmp directory. In my case is tmp. You can customize as you wish. Detector underscore run underscore dir. Here we go. And the state will be absent because we would like to verify that this directory is not present on the target system. Let me also verify my boolean, that will be clean underscore run underscore before, set to true. Okay, next step will be to create the detector run directory. So with the previous one we verified that run directory doesn't exist, and if exists we remove, and now we create an empty one because this detector requires empty directory to execute. So ansible.builtin.file, let me specify the path that will be exactly the same as the previous task. So detector underscore dir, and detector underscore undir. Here we go. This case, the state will be directory, so Ansible is going to create a new directory. So combined together, these two steps will create an empty directory, for sure. Finally, we are ready to run the code. Yes, are you excited? Let's go. So run detector/scanner will be a pretty good name. To execute, I'm going to use ansible.builtin.shell module again. Let me specify the path, so the detector dir, and then the name of my shell script, sh detector. We need to add also two other parameters. The first is the detector options, is the variable that we specified before. So all the option is going to be added here in the command line. And there is a special moment to add also --tmp, that is the temporary directory where the detector effectively run. And we define it like always, concatenating detector underscore dir, and in my case it's detector underscore run underscore dir. So here we go. Finally, this line is going to execute all the detector code and verify if our system is vulnerable or not. Next step will be to save the file created by detector under the run directory. So let me use ansible.builtin.find module. In my paths will be the value of the run directory. So as usual, detector underscore dir concatenated with detector underscore run underscore dir. You see, is wonderful. And we can save the result and vulnerable the variable. This is an easy way to print it out on screen. So let me print the vulnerable paths. But you can also perform any further action in Ansible. Now ansible.builtin.debug module, and simply specify var parameter to print it out the variable on screen. Here we go, and the last step will be to clean up the detector directory if we want. So remove detector directory. Let me use, as before, ansible.builtin.file. The path will be the value of a variable detector underscore dir, state absent, and we would like to condition this to the when how was the name of the variable? Delete underscore after set to true. Here we go. You see, we have our playbook to run the detector and creating all the necessary preliminary options. Let me zoom it out so we can have all the view of this stuff. We install the unzip software. We create one temporary directory for all the relevant files. We download the file from the internet. We verify the GPG signature. We create a running directory, verify that it's empty, and finally run the detector code completely automatically and print it out the result on screen. So great. Only 60 lines of code, and we are able to use the official Red Hat detector script completely automatically in all our fleet. This is devsecops. Yes, great. Let me fix it out. Only one little typo. that will be under the remove any detector run directory. Yes, I need to verify the condition will be here equal to true, and now the playbook is completed. Let's jump to the console for see the execution. Welcome to my console. I'm going to show you the execution of my playbook running the detector against my demo host demo.example.com. That is defined inside the inventory, so Ansible-playbook-e my inventory file and my playbook file. Is the first connection, as you can see, so I need to accept the SSH key. First task is to include the variable, then we start the true real execution. First step, we need to install the dependency. It's going to take a while because we are going to refresh also the repository metadata. And using the package manager of the distribution, we are going to install the unzipped utility, then create the detector directory and download the file directly from the Red Hat website. Files, first is the detector and the second is the public key to verify it. We are fetching the public key registry, in my case the MIT database, to fetch the Red Hat product security key. It's going to take some moment, just time to wait and fetch the public key to verify the script. Here we go. Finally, the script is already verified. We create now the run directory and we are ready to run. The detector scanner is going to take a while. It depends how many files, the performance of your system and the underlying file system. The default is going to scan all the var partition and printed out the result on screen. In my case, as you see, the files list is empty, so there will be no files under the run directory. Let me connect to the target machine because as you can see, I was not removing the detector directory, so we can take a look of the hierarchy inside. So this machine is not vulnerable to the log4j. Let me connect via SSH to the target machine to verify the directory structure. So SSH DevOps is my username at demo.example.com, and it's going to take a while. My network connection is a bit slow today. Let me connect again. Let me type again my... Oh, here we go. Now we are inside the virtual machine, and let me list the content of my detector directory that is under TMP. I created the CVE path. As you can see, there is the detector bash script and the public key. Under the TMP, the script creates a report directory where all the txt file of the running vulnerability are going to create. In my case, there is none, so which means that this machine is not affected by this flow. So great, let's celebrate! And good job, Ansible! Now you know how to automate the detector of Log4Shell remote code execution Log4j CVE-2021-009 on Linux with Ansible. Thank you for watching. If you enjoyed this code, write a comment, give me a thumbs up, and keep in contact with me. And see us on the next IT adventure of Ansible Pilot. This video is part of our Ansible automation program. Sign up today on www.ansiblepilot.com for uninterrupted exclusive video and so much fun.